And I'm Jane. We're here to teach you about
irradiated foods!
So you might be asking, what are irradiated foods?
Well, irradiated foods are foods that have been exposed to high energy waves such as gamma rays or high electron beams in order to maximize food safety. It kills bacteria like E. coli and Salmonella.
So how did scientists come up with this technology?
Well, in 1905, scientists received patents to use ionizing radiation to kill bacteria in foods. In the 1920s, an scientiste français, or in American we would say a French scientist, discovered that irradiation could be used to preserve food.
During World War II, the U.S. Army experimented with different food preservation techniques and experimented with irradiation. This was a useful and successful experiment which led to the first FDA approval of its use to control insects in wheat and wheat flour in 1963.
Then shortly following, in 1964, the FDA approved irradiation to curb the development of sprouts and white potatoes. 20 years later, in 1983, the FDA approved irradiation for the control of microorganisms and killing of insects in herbs, spices, and vegetable seasonings.
In 1985, the FDA approved the treatment of pork to control bacteria known as trichinosis. In the same year, they approved the control of insects and microorganisms in dry enzyme preparations used in certain processes involving fermentation. In 1986, the FDA approved a similar treatment for fruits, vegetables, and grains.
In 1990, the first approval of cold pasteurization of solid foods such as poultry went into effect. Later in December of 1997, approval for irradiation of red meats with controlled doses of KGY and later higher doses were approved for sterilization of frozen and packaged meats. Unfortunately, this is only available to NASA.
Recently, there is current legislation being passed through that will allow the irradiation of seafood, and as of March 2003, irradiation of foods has been approved in more than 50 countries.
Now, how does it work?
In normal unstressed cells, the level of p53 protein is downregulated via the binding of proteins such as MDM2.
Noel, Jane, let's not get carried away with this fancy talk. Here's a better explanation.
Irradiation kills organisms that cause foodborne illness. As in the heat pasteurization of milk, the irradiation process greatly reduces but does not eliminate all bacteria. Irradiated meat, for example, still requires refrigeration, but would be safe longer than untreated meat.
The energy source is either gamma rays produced by a radioactive element such as cobalt, or electrons produced by electricity, measured in kilograms or kGYs. The ionizing rays evenly penetrate the food, breaking up the bacteria's DNA, making it impossible for the bacteria to reproduce or continue living rapidly, killing food-poisoning bacteria, harmful parasites, or insects. Irradiated foods are not radioactive since the rays do not remain in the food.
What happens when food is irradiated? It doesn't increase the temperature or change the food's appearance. The gamma rays are more penetrating than, say, for example, microwaves, which actually cook food.
Sounds too good to be true, Jane. That's why there have been new findings about the hidden dangers of irradiation, which may worry some people. The FDA has gotten weaker with food regulations, which is clear because the budget for food regulation was reduced from 50% to 25%. People who oppose the radiation talk about many problems with the irradiation process. Radiation doesn't kill viruses and doesn't kill all foodborne pathogens.
People against irradiation cite several reasons for not advocating it. Irradiation damages the quality of food. Science has not proven that a long-term diet of irradiated foods is safe for the human health. It covers up problems that the meat and poultry industry should solve. Electron beam irradiation today needs nuclear irradiation tomorrow. Irradiation using radioactive materials is an environmental hazard. Irradiation does not provide clean food.
Irradiation damages food by creating free radicals. They kill some bacteria, but they also bounce around in the food, damaging vitamins and enzymes, and combine with existing chemicals, like pesticides, in the food to form new chemicals called unique radiolytic products, or URPs. The long-term effects of these new compounds have not been studied, so we can't assume they are safe. Irradiated foods can lose 5% to 80% of many vitamins, depending on the dose of irradiation and the length of storage time. It damages the natural digestive enzymes for in raw foods, which means the body has to work harder to digest them. Irradiated fats tend to become rancid.
The long-term effects of a diet of irradiated foods haven't been proven. The longest human feeding study was only 15 weeks, and there are no studies on the effects of feeding babies or children irradiated diets. The FDA based its approval on irradiation for poultry on only 5 of 441 animal feeding studies. The 5 studies are not a good basis for approval of irradiation for humans because they showed health effects on the animals or were conducted using irradiation at lower energies than those the FDA eventually approved. Studies on animals fed irradiated foods have shown increased tumors, reproductive failures, and kidney damage.
Irradiation covers up problems that the meat and poultry industry should solve, such as increased fecal contamination that result from speeded up slaughter and decreased federal inspection, both of which allow meat and poultry to be produced more cheaply. This lack of regulation allows for more bacteria to remain contaminated because irradiation doesn't sterilize food.
Many foods can be irradiated using electron beams because they are only suitable for penetrating flat, evenly sized foods like patties. Countries that lack a cheap and reliable source of electricity for E-beams use nuclear materials. Opening U.S. markets to irradiated foods encourages the spread of nuclear irradiation worldwide. This can lead to more nuclear waste. The more nuclear irradiators there are, the bigger chance of a serious accident in transport, operation, or disposal of the nuclear materials.
Irradiation doesn't kill all the bacteria in a food, and people may become more careless about sanitation if irradiation is widely used. Current doses of irradiation don't kill viruses and prions, which are believed to cause mad cow disease. And as mentioned before, irradiation encourages food producers to cut corners on sanitation because they can clean up the food just before it is shipped.
Because of these concerns and problems, there isn't much promise for irradiated foods to last in the food industry for very long. However, organizations like the American Council on Science and Health are trying to push irradiated foods as an effective sanitary treatment that will provide consumers with safer food and a wider choice of fresh fruits.
We believe that if there were more regulations on the FDA's part through clear labeling and more awareness on the public's part of the pros and cons of irradiation is an effective way to make food safer.
To sum it all up, irradiation is a treatment of food with electron beams, or gamma rays, to kill certain bacteria and to help food last longer. There are concerns about the effectiveness of irradiation and whether it is safe to maintain a diet based on irradiated foods. As a consumer, you should always be aware of what products you buy and to stay informed. Always clean produce thoroughly and prepare meats in a proper manner.
Thanks for watching,
and we
hope you learned a lot. We sure did.
Bye!
We're no strangers to love. You know the rules, and so do I. I feel commitments while I think.
모의 demo.